In this video, I'm going to show you how to integrate functions using polynomial division. So here for our first problem, we want to compute the integral of 3x plus 1 over x plus 2 with respect to x. Now, at first glance, this integral looks a bit tough because it's a rational function. But it's actually quite easy if we do synthetic division first, so that we convert this rational function into a polynomial plus a reciprocal function. Now here's a brief reminder of how synthetic division works. First, we set up our corner. And in this corner, we start by filling in a top row. The first entry, outside the corner, is going to be the root of the denominator. So what value of x makes this denominator x plus 2 equal to 0? Well, that would be negative 2. So that's what we put up here. Then the rest of the top row consists of coefficients of the numerator. The x coefficient is 3, and the constant is 1. Now we go through a repeated process of adding and multiplying. Starting by filling in under this first entry with 0, we add down the column, 3 plus 0 is 3, and then we multiply negative 2 times 3 to get negative 6, which we put in the next column under the 1. Then we add 1 plus negative 6 is negative 5, and we've reached the end. This bottom row gives us the coefficients for the result, with the last entry in this row corresponding to the remainder. So this is really telling us that our rational function here, 3x plus 1 over x plus 2, is equal to 3 with a remainder minus 5 over the original linear factor x plus 2. So let's take this result here and let's put that in for the rational function in the integral. So this will become the integral of 3 minus 5 over x plus 2 with respect to x. Breaking this up, the integral of 3 is just 3x, and then minus 5 times the integral of 1 over x plus 2, which is the natural log of x plus 2. And don't forget your constant of integration, c. So there we go, that's it. That wasn't too bad. All we had to do was perform synthetic division and then integrate the result. Here's the next problem. We want to compute the integral of 2x cubed plus 2x squared plus 1 all over 2x plus 1 with respect to x. And again, since this is a rational function, we're going to simplify it using synthetic division. Before we jump into synthetic division though, remember that synthetic division only works when the denominator is a linear factor with a leading coefficient of 1. This denominator here is a linear factor, but it has a leading coefficient of 2, and we want to get that down to 1. So what we can do is we can factor out that 2. We'll just write this integral again, once more factoring out that 2 from the denominator. So numerator stays the same, 2x cubed plus 2x squared plus 1. And then in the denominator, we'll factor out the leading coefficient of 2, and then 2 times x makes 2x, and 2 times what makes 1? Well, 2 times a half makes 1. And now we can even factor out that 2 even further outside of the integral. This is really just the integral of 1/2 times that fraction, 2x cubed plus 2x squared plus 1 all over x plus a half. And we know that we can factor out constants outside the integral. So this is 1/2 the integral of 2x cubed plus 2x squared plus 1 all over x plus 1/2. Alright, finally we have our rational expression in a form that allows for synthetic division. So let's set up our corner. And let's fill in our first column, starting with the first entry, which is outside of the corner. And that just comes from the 0 of the denominator. So what value of x makes x plus a half equal to 0? Well, that's negative 1/2. Then the rest of that first row consists of the coefficients of the numerator here. Now keep in mind we have to write these coefficients perfectly in order, starting from the greatest power of x and going down to the constant. And we also have to include any 0 coefficients. Like, for example, there is no x term here. So really, the coefficient of the x term would be 0. So let's write this down. Coefficient of x cubed is 2. Coefficient of x squared is 2. Coefficient of x is 0 because that doesn't appear at all. And then the constant is 1. Just for clarity's sake, let's write the powers of x above. So x cubed, x squared, x, and constant. Now we kick off the synthetic division process, starting with a 0 in this second row. Then we repeatedly add down the column and multiply by this negative a half. So 2 plus 0 is 2. Then multiply by negative a half to get negative 1. 2 plus negative 1 is 1. Multiply negative a half times 1 is negative a half. 0 plus negative a half is, well, still negative a half. And negative a half times negative a half is positive 1/4. Lastly, 1 plus 1/4 is 1 1/4, or 5/4. Now this bottom row gives us the coefficients for our result, with the last entry, 5/4, corresponding to the remainder. So if we work backwards, that 5/4, that's the remainder. Negative a half, that's the constant. What comes after constant? Well, x. Then after x is x squared. So it's really like these powers of x have just shifted down a power. X cubed goes to x squared goes to x goes to constant goes to remainder. So the overall result, what this is telling us, is that our fraction 2x cubed plus 2x squared plus 1 over x plus a half is equal to 2x squared plus 1x, so just leave that as x, plus negative a half, so minus a half, and then plus our remainder of 5/4 over the original denominator, x plus a half. So we take that result, we put that in for the fraction in our integral, and we end up with the integral that is much easier to compute. So integral of 2x squared plus x minus a half plus 5/4 over x plus a half with respect to x. And we just integrate that, so this is 1/2 times integral of 2x squared. Well, that's 2 times a third x cubed, so 2/3 x cubed. And then integral of x is just 1/2 x squared. Integral of a half is just a half x. And then this last term would be 5/4 times the integral of x plus a half, which is natural log of x plus a half. And then don't forget at the very end your constant of integration. Lastly, just distribute through that 1/2. So a half of 2/3 is 1/3. So 1/3 x cubed. Then a half times a half is 1/4. So a fourth x squared. A half times a half, still a fourth. So minus 1/4 x. And then a half times 5/4 makes 5/8. Then natural log of x plus a half, plus our constant. So there we go. There is our result. Again, it looked pretty scary at the beginning, but after we did synthetic division, the integral became much more approachable and it was very easy to integrate. So now we know how to integrate functions using polynomial division. And in the future, we'll learn even more techniques for integrating functions, such as completing the square.